Good evening guys, we are back with another problem, and today's problem is about string subsequence. So I hope you all are doing very well, and in string subsequence we are again going to go with the DP series of DP number 6, and today we are going to understand the subsequence. In previous videos we have learned about the longest subsequence problems and the longest chain of subsequent problems. In today's problem statement we are going to learn about the string subsequence. So string subsequence is basically it's like that there will be two strings and we have to count the number of subsequence of strings which are equal to the string s2. So if you see that there is a given string s1 is geeks for geeks and the given string s2 is gks. So I'm going to just quickly take the example and just elaborate it over here. So if you take it the example like this, that s1 is equals to geeks for geeks, okay, and now we have to also check into account s2 which is GKS. So our primary task is to check the number of times this GKS occurs within the bigger string S1. So you can write over here the possibilities over here as like this, that the possibilities are, you can see GKS occurs in which index of this particular string. So if I name the index as 0 1 2 3 0 1 2 0 1 2 3 4 5 6 7 8 9 10 11 12. Okay, so let's just quickly check the possibilities. So GKS, so the possibility can be 0 3 and 4. This is the first possibility, 0 3 and 4. The second possibility can be GKS, right? Second possibility can be 8 11 and 12, 8 11 and 12. Okay, and the third possibility, if I see the third possibility, what can be the third possibility? Let's just check GKS. I can take 0, I can take 0, and then 11 and 12. These are the three possibilities. How many other possibilities I can take? I can take geek for geeks. Okay, just let me check, is there any possible? 0 3 4 I have taken, 0 3 4 I have taken, 8 11 12, 8 11 12 also taken, 0 11 12 also taken, 0 3 12. Okay, so 0 3 12, yeah, so 0 3 and 12, these many possibilities are there. So there is 4 possibilities and we have to print the 4 possibilities. So how we are going to do this? So obviously this can be done using a brute force method, but usually the time complexity of the brute force method is a little bit higher. So we want to reduce the time and space complexity. That's why we want to use a dynamic programming approach. So I can write over the dynamic programming approach. So in this approach, what I'm going to do is I'm going to just take the two strings and give them two arrays, right? So this S1 or the main string will be governed by the I array. Okay, so in the I array there will be elements G, E, E, K, S, F, O, R, G, E, E, K, S. So you can see this is the I array. In the S2 or with the subsequence array or the special target array, I will only have the 3 elements, which is G, K and S. So the counter of these two arrays are used by the I array is used for this counter and the J array is used for this. So I and J. So now my question goes like this, that if I get the two, I will have an option of taking and not taking. So first my primary goal is S1 of I is equals to S2 of J. Okay, then what will I do? So there will be two options for me. Okay, so the two options is take, and the second option is don't take. Okay, so in this case where S1 of I is equals to S2 of J, in the take option, what I can write the series like this, that my series will move in the direction of both I minus 1, J minus 1. Okay, I minus 1, J minus 1. So I can write it over here as dp of I and J equals to this will move. So why I minus 1 j minus 1? So basically you can check it like this, that whenever you are going I minus 1 j minus 1, you can just go and traverse over here in this direction and in this direction. So usually why I'm going I minus 1, because the starting position, the starting value will be the last value. I will start from the length. Okay, I will start from the end. So from this end, I will go I minus 1 direction. Similarly, in the small string, I will go in this direction, I minus 1, j minus 1 direction. Okay, so this is my take condition. Okay, so what if I don't want to take? Okay, what if I don't want to take? Then I will only move in the I minus 1 and remain constant in the j direction. Okay, so this part will not be moving, and only this part will be moving, and I will be traversing through it and keep on checking the elements. So say for example, I am checking the value of s which is present over here. So s will be checked through the entire array, and when I am going to check individually all the other elements like k, g, then I am going to move the 2 pointers. Otherwise only 1 pointer is going to move. Okay, so this is the condition where the 2 strings are equal. But what if s1 of I is not equals to s2 of j? Then what we are going to do? That means like the 2 strings are not equal. Then also I'm going to follow the condition of only moving I component and keeping the j component constant. Okay, so that is how I'm going to do the problem. So let's also check one condition over here, that if the value of j is lesser than 0, then we are going to return 1, and if the value of I is lesser than 0, then we are going to return 0. Okay, so let's check the problem. So it is saying that since the first over here you can see we have taken a function of integer return type, has 2 parameters s1 and s2. Initially I'm going to take the length of the 2 strings. Modulus constant will store the modulus value of 10 to the power of 9 plus 7. There will be DP array with the limits n plus 1 and m plus 1. Now we are going to fill up the DP array. One way to fill up the empty subsequence is DP of I and z equals to 1. So this is why first we are going to make the DP table empty and then fill it up with 1s. Okay, in the I component. Now we are filling the DP array. First we are going to traverse to the two strings. I and j counters are used to traverse to the 2 things. Now you can see I have done that s1 dot caret of I minus 1 is equals to means it is basically saying that the character presented I minus 1 is equals to character presented j minus 1. So I will move in both the directions. You can see I have calculated over here. I will move in I minus 1 and j minus 1 direction, as well as I minus 1 and j. Or else if I am not able to take it, then I am going to move in dp of I and j is equals to dp of I minus 1. So only move in the one particular direction. Lastly, I am going to return the entire array which I have found and formed, and total number of counts of the elements by return dp of n and m. Okay, so that was about today's problem. So we are going to submit this problem. So we have successfully completed today's problem. We are looking forward to solving more DP series and more interesting problems of DP series.